Welcome. This question says a 5 cubic meter block of material has a density of 7 kilograms per cubic meter, is placed under the surface of a fluid as a density of 9 kilograms per cubic meter. What will the object do? Well, conceptually, I'm putting a low density material underneath the surface of a high density material, a high density fluid. And therefore I know that this thing is going to accelerate towards the surface. But let's see if I can prove that using some numbers. So here's my visualization. Here's the surface, and here's my block. And I know that this is 5 meters cubed, and I know that this is 7 kilograms per meter cubed. I know my units well enough. I don't need to label this as a density. I know it's a density by simply looking at the units. And then the actual fluid is 9 kilograms per meter cubed. Well, that needs to be a dividing sign there as well. Let me move this over just a little bit so I can actually draw some arrows in. So this is going to be a 9 kilograms per meter cubed. And we're going to end up with two forces. We're going to end up with a buoyant force, FB, and we're going to end up with a weight, FG. I don't know which is bigger until I do some numbers. I can say the sum of my forces vertically are equal to, well, it's going to be FB is pointing upwards and added to, well, FG is going to point downwards. It's got a negative sign on it. So the sum of my forces vertically. Now, where does this numerical value come from? Well, it's going to be the buoyant force, so it's the density of the fluid times G times the volume of the displaced fluid. It's all about the fluid and the volume that's displaced. And we add on to that a minus. And this is the object. This is the weight of the object, which is the density of the object times G times the volume of the object. Okay? Let's try and put some numbers in. The sum of the forces vertically is going to equal, well, we actually do know the density of the fluid is 9. And we know G is 10. And we know the volume of displaced fluid is 5. And we know that let's put a negative sign down for this, the density of the object is 7 times 10 for G, and we know that the volume of the object is the same as the volume of the displaced fluid, so this is also 5. So we end up with the sum of the forces vertically are equal to 9 5s are 45, that's 450 pointing upwards, added to 7 5s are 35, that's 350 pointing downwards. Sum of the forces vertically equal plus 100 newtons. If I have a net force upwards, then I will have, so the object accelerates upwards. If the acceleration is upwards, if the net force is upwards, then the acceleration is upwards. Frankly, the water resistance forces are so great that it quickly reaches terminal velocity. So it doesn't continue to accelerate. If you let it go at any distance below the surface, it will reach a steady speed and cruise to the surface, but it will travel upwards towards the surface. And there we have it.